so let's start today's class. Today's class is about the climate change and society. So I'd like to talk about today's topic is not so scientific as usual, but I'd like to talk about the relationship of the science and society. Okay? And today's keywords are the first one is an intergovernmental panel of climate change, and the second one is geoengineering. Okay, so first, this is a quiz. Who won the Nobel Peace Prize in 2007? Do you know? Okay, no one knows. Yeah, the answer is IPCC Intergovernmental Panel on Climate Change and Al Gore. And this Nobel Prize is for their effort to build up and disseminate greater knowledge about man-made climate change and to lay the foundation for the measures that are needed to counteract such change. So, yeah, I will talk about IPCC today, but do you know who is Al Gore? Maybe you know. No? Yes.
He was the vice president
yes.
for Bill Clinton.
Yes, yes.
He's been very outspoken about the climate change.
Yes, exactly. Yes. Yeah, he is a vice president in the U.S. from 1993 to 2001. And at that time, the president of the U.S. is Bill Clinton. And he's very famous for this film, An Inconvenient Truth. Have you ever seen this film? No. No. Yeah, this film is very good. Yeah, you should see this film rather than my class. This film is about the climate change, ongoing climate change, and Al Gore wrote some climate change about some climate change, and some director made this film from that book. Okay, so now I will explain about IPCC now. Have you ever heard about IPCC? Yes, oh, everyone knows, okay. IPCC is the Intergovernmental Panel of Climate Change. This panel was established in 1988 by two United Nations organizations. One is the World Meteorological Organization, and another one is UNEP, United Nations Environmental Program. And the office of the WMO is located in Switzerland, Geneva, and the headquarters office of UNEP is located in Nairobi, Kenya. Okay, so the role of IPCC is to provide governments at all levels with scientific information that they can use to develop climate policies. And they made reports for the climate change issue. And IPCC reports are also a key input into international climate change negotiation because climate change issue is not only the national problem, but also the global problem. So we have to discuss with other countries to take some countermeasure for the climate change. And for the IPCC reports, an open and transparent review by experts and governments around the world is an essential part. To ensure an objective and complete assessment and to reflect a diverse range of views and expertise. So the IPCC is, in the IPCC, many scientists and government people are working together to make a report for the climate change. And this report is very important to take a countermeasure of climate change. There are 3 working groups in the IPCC. We call working group 1, 2, and 3. And first one is the physical science basis. This working group is to evaluate of the natural scientific basis for climate system and climate change. So this working group 1 is a very scientific part of IPCC. And working group 2 is for the impacts, adaptation, and vulnerability. And this group will assess of socio-economic and natural system vulnerability to climate change, and positive and negative effect of climate change, and option for adaptation to climate change. So this part is a little bit not scientific, not only scientific, but also social and economic part of IPCC. And working group 3 is, this working group is work for the mitigation of climate change. And their purpose is assessment of climate change mitigation options such as reducing greenhouse gas emissions. So this part is the industrial or technology part of the IPCC. Yeah, of course, the social science will contribute this working group 3. But yeah, so these 3 are the main working group in the IPCC. Okay, and this is the history of IPCC reports. IPCC is established in 1988, and they published their first report in 1990s. These reports, we call this report assessment report. So usually we call that report AR. So first one is first AR, so FAR. Second one is SAR. And the latest one is AR5. We call AR5. That one is established in 2014. Okay, first one is published in 1990s. So now, so far, we have 5 reports like this. And the next one will be published in 2022. So now there are many scientists and government people are working on completing these reports now. And okay, so to sum up each report, reports are, they have a chairperson, and the chairperson has changed. And first and second assessment report, Bert Bolin, he's a Swedish scientist, chairs this committee, And the third one is Bob Watson. He's a British. And the fourth and fifth one, the Pachauri, Rajendra Pachauri-san. He's an Indian scientist, chaired these committees. And now the Ho-Sun Lee, he's a Korean scientist. He's now chairing the IPCC reports. Okay. And okay. Okay. So let's see how is the IPCC's website. And yeah, it's a little bit difficult to see, but here we found the report. And this is the latest report, and this is a sixth assessment report, but it's not completed. And the latest one is a fifth assessment report, AR5. Let's see this one. Okay, so yeah, this is our IPCC report, AR5, or this report is worked by the working group 1, just a physical and science basis. And everyone can see these reports if you want. But the full report is about 360 megabytes, so it's very big. And they have these chapters, for example, introduction, atmosphere and surface, ocean, cryosphere. Cryosphere means the cold Arctic region. Paleoclimate, aerosol and cloud, and the simulation, climate model, like. And if we read these reports, okay, so everyone can see this report, but this report is very long. For example, the first assessment report, the total pages is about 360, but now the latest one is more than 1,500 pages. But the objective of IPCC is to provide the governments at all levels with scientific information that they can use to develop climate policies. So, but the government people is usually very busy, so they have no time to read all of these reports. So the IPCC always make this kind of document. We call this one Summary for Policymaker, SPM. So in the SPM, the contents of reports is summarized and very concisely. So government people can easily read, and they can easily use that information for the policymaker. Okay. For example, the summary for policymaker SPM of the working group 1 report is only 29 pages. It's very concise, like this. So maybe please look at this one. And in Japan, we can read this SPM in Japanese because some ministry or agency translate this SPM to Japanese. So for example, working group 1 report, the Japanese Meteorological Agency, Kishoucho, translated this report, this SPM, and working group 2, Ministry of Environment, Kankyosho, translate this SPM. And the working group 3, Ministry of Economy and Trade and Industry, this is Keizai Sangyosho, Keisansho in Japan, translate this the SPM, and they upload this translated version on the website, so you can see this material on website. So let's look at our example of SPM statement, IPCC SPM statement. There are many statements, and all of them are itemized and in each chapter. But there are a little bit complicated, how to say, the term in the SPM. So I will introduce, I will talk about this now. Okay, for example, first one, it is virtually certain that globally the troposphere has warmed since the mid-20th century. And second one, changes in many extreme weather and climate events have been observed since about 1950. It is very likely that the number of cold days and nights has decreased and the number of warm days and nights has increased on the global scale. The third one is equilibrium climate sensitivity. This means it is defined as a change in global mean surface temperature at equilibrium that is caused by doubling of the atmospheric CO2 concentration. This climate sensitivity is likely in the range 1.4 Celsius degrees to 4.5 Celsius degrees, extremely unlikely less than 1 Celsius degrees, and very unlikely greater than 6 Celsius degrees. So in this SPM, they frequently use these terms, like virtually certain or very likely, extremely unlikely, or very unlikely. But so first you solve that document. You feel very uncomfortable for these terms, but they have a definition of these terms. So before you read this SPM, you have to know about that. This is a specific language the IPCC uses. They often use these terms, but all of these terms are based on the probability. So if they use very likely, this means 90 to 100% probability. And if they use very unlikely, this is 0 to 10% probability. So you have to know about these probability terms before you read the SPMs. But the SPM is very concisely summarized, so maybe you can read very smoothly, I think. So yeah, this means to understand this scientific report, at least you have to have the knowledge about the statistics or probability, mathematics, Okay. And yeah, the one of the very important part of the IPCC report is the scenarios used to project climate change, because all of us are interested in how the Earth will change. So to predict the climate change, we usually use simulation by numerical models, and that's in that simulation they consider not only about the atmosphere but only about the ocean, land use, troposphere, stratosphere, and all of things in the surface area of Earth. And okay, so yeah, before I explain these tables, and I want to explain about this RCP. They have in that IPCC reports, they propose these 4 scenarios, and we call these scenarios RCP. The RCP means representative concentration pathways. That term is not hard to understand, but the concept is these things. The climate change projection in IPCC Working Group 1 require information about the future emission or concentration of greenhouse gases. GHG is greenhouse gases like carbon dioxide, methane, or N2O, and ozone, like that. Aerosols and other climate drivers. And so this information is often expressed as a scenario of human activities. And so these scenarios used in Working Group 1 have focused on anthropogenic emission, and that they do not care about the natural change, like volcanic eruption or change of solar activity, because that is not they are unpredictable. So they do not take care about that, but only they care about the anthropogenic emission of greenhouse gases and aerosols. And in the 5th assessment report of IPCC, they propose 4 scenarios denoted representative concentration pathways, RCPs. And these 4 RCPs are identified by the approximate total radiative forcing in year 2100 relative to 1750. Okay, this is very complicated, but and I showed this figure several times, and so this figure is important to understand about this value, radiating forcing relative to 1750. So if the radiative forcing is positive, this means global warming. this is a balance of the radiation. If they are positive, this leads to the global warming. But if this is negative, the Earth will cool. And each species have their own radiative forcing values. For example, CO2 has a positive value. The top one, positive value about 1.7 or 6 something. And the methane, N2O also have positive values. And the aerosols have a negative value. So negative value like this. And so this means that aerosol can cool down the Earth. And this is a summary of the radiative forcing. And in 2011, the radiative forcing value is about 2.2 or 2.3. And now this value is increasing. So, for example, in this scenario, there are 4 radiating forcing values. This is radiative forcing value in year, this one, relative to 7050. So, in this scenario, its radiating forcing value is not increased so much if compared to now, because now the value is about 2.2 or 2.3. So if we keep these values, the temperature at the end of the 21st century is about the global warming is about 1.1 Celsius degrees. But if we achieve these values, we take maximum measures, countermeasures for global warming. But if we do not take any measures, the radiating forcing will be increased to 8.5, and this causes the global warming at 3.7 Celsius degrees. Okay, so let's see more. And this figure shows the carbon emission by fossil fuel burning by the 4 different RCP scenarios. And this black line showing the data by far, the observation data by now. And for example, in this scenario, LCP 2.6, in this scenario, we will stop the carbon emission by fossil fuel burning in 2020 or 2030, and then this emission will decrease like this. In RCP 8.5 scenarios, we do not stop carbon emission. We do not stop burning fossil fuels. So the carbon emission will increase like that. Then this small figure shows the change of concentration of carbon dioxide based on these emission values. And in this scenario, RCP 2.6 scenario, the CO2 concentration will decrease like this. But in the RCP 8.5 scenario, carbon dioxide concentration will increase to 800 ppm by the end of the 21st century. This is almost double of the concentration in present. Then, what's the climate? How the climate change? This ABC panel shows the global surface temperature change and sea ice content and the global surface pH based on these scenarios. So, okay, let's look at this one. This is a global average surface temperature change. And, in the RCP 2.6 scenario, the change of surface temperature is not so apparent. It's about one global warming value is about 1 Celsius degrees. But in the RCP 8.5 scenario, the global warming is about 3.7 or 5 Celsius degrees. Let's see the ice content in the northern hemisphere. And now the ice area of northern hemisphere will decreasing, especially in the Arctic Ocean. This black line is observation data, and if in the RCP 2.6 scenario, the ice content will decrease, but not so. After the 2050, this decrease rate is not apparent and almost constant. But in the RCP 8.5 scenario, the ice content in the northern hemisphere is almost zero in the 2060 or 70. And this is about the global ocean surface pH. So I didn't explain about the acidification of ocean due to the global warming. But if the CO2 concentration of the ocean will increase, the pH of the ocean will be decreased. And then there are these cause it's not very good for the ecosystem because some shell or coral reef will impacted by the pH decrease. Okay, so do you understand about these scenarios? Okay. Okay, so let's move on to the next topic. This is a Paris Agreement. Have you ever heard about the Paris Agreement? Okay, this agreement is adopted at the COP21 in 2050, and they showed that the proceed of effort to keep the global average temperature rise well below 2 Celsius degrees and to 1.5 Celsius degrees compared to before the Industrial Revolution. So after this Paris Agreement, the IPCC showed and make this report. And they show that the global warming is likely to reach 1.5 Celsius degrees between the 2030 and 2052 if the current global warming continues. So this means if we keep this agreement, we have to do some. We have to work on some countermeasure of global warming. Okay. So this is one of the important figure in this report's global warming of 1.5 Celsius degrees. You can also read this report. You can download this report from IPCC website. So if you interested in, please do. And this is the one of the important figure from that report. And this figure shows observed global temperature change and modeled temperature change in future. And the x-axis shows the years, and the y-axis shows the global surface temperature. And these gray line shows the observation data from 1960 to 2070. So as you can see, the global temperature has been increased like this. And these shades, green, gray, and purple shades, are showing the simulated result based on the carbon emission. And if we stop carbon emission, CO2 なんて書けばいいかな。CO2 emission. So, and this, and okay, so, okay. So, yeah, let's look at these gray shades. If we stop if we start to reduce the carbon fossil fuel burning, and then the net global CO2 emission will be reached zero in 2055. Then, okay. Then the global temperature will almost constant after the 50 or like this. But this is a scenario if we stop the fossil fuel burning now. But so if we, so this means if we stop the fossil fuel burning now, and then we can keep the Paris Agreement of this to keep the global average temperature rise well below 2 Celsius degrees. But if we continue to burn fossil fuel like now, we will not able to keep that agreement. So now there are many countermeasures for global warming, and each country have a responsibility to keep the Paris Agreement. And okay, so yeah, there are many ways to reduce the carbon emission, but there are very for example, making the hybrid car is also the countermeasures for the global warming. But now there are several ways to try to change the global climate very drastically. Have you ever heard about the geoengineering? No? Yeah. So I want to explain about geoengineering in the latter class, in this class. And this is a large-scale modification of the global environment against climate change. This is a very big project. So, and now many scientists and technicians will think about this engineering, but not so far. I think this engineering is not commercially used in worldwide, but the concept is very important, and maybe in the future we have to do geoengineering against the climate change. Okay, so this is a schematic of geoengineering. There are many kinds of geoengineering. For example, yeah, here there are two types of geoengineering. First one is a carbon dioxide removal. So this, and second one is solar radiation management. Okay, so let's, for example, in the solar radiation management, there are many ways to do this. And for example, deployment of space mirrors, G, this one. This is put the mirrors in the sky, and this mirror can reflect the sunlight directly to the space. Maybe some of you, it's very ridiculous way, but some seriously thinking about these things. And another one is H. It's a stratospheric aerosol injection. This means inject the aerosol in the stratosphere. I explained about the large volcanic eruption will decrease the temperature, because if the plume of the eruption reaches to the stratosphere and eject some aerosol to the stratosphere, and the lifetime of the aerosol in the stratosphere is very long. So the sunlight scattered by the aerosols, and this effect lasts for a long time. So, but we do not expect a large volcanic eruption. So this is we actively inject the aerosols to the stratosphere. And another one is marine cloud brightening. This one. About this I will explain later. And for J is ocean brightening with microbubbles. So if we make many microbubbles in the ocean, the color of bubbles looks like white. So these bubbles can reflect the sunlight to the space. And K is a crop brightening, or L is a whitening rooftops. This is very easy. Just paint the white paint on the rooftop. But it will maybe it will work because the albedo is a very important part to think about the climate change. So this is very easy, but it will works well. I think so. And another geoengineering is a carbon dioxide removal. This is remove the carbon dioxide from ocean or atmosphere directly or indirectly. A is ocean fertilization. I explained about iron fertilization in the ocean. And this is a kind of carbon dioxide removal geoengineering, but indirect one. And B is alkalinity addition to the ocean, because if the concentration of carbon dioxide in the ocean, pH will decrease. So we, in this geoengineering, we add some alkalinity artificially to the ocean and mitigate the ocean acidification. D is a direct air capture. So this means it directly catch up the CO2 from the atmosphere and transport this CO2 to underground and separate to the atmosphere. Okay, there are many ways to remove the carbon dioxide from the atmosphere. Okay, so, but this geoengineering concept is not so new. There is a history of the geoengineering. First, this engineering is conducted for the artificial rainfall research in 19th centuries. So, because some country in dry region, the rainfall is a very critical problem. So, first this geoengineering is start for the artificial rainfall research. And then in the 1960s, geoengineering as a measure against global warming first appeared in the literature. This is in the report for environmental issue by United States. And there are statements about geoengineering in IPCC reports in the first and the second one. But initially, this statement was treated, this statement says geoengineering is not so good. So it was treated negatively. But after the 21st centuries, geoengineering research as a countermeasure against global warming has become very popular. Okay, so before talk about the countermeasure of the global warming, I will talk about the artificial rainfall. So the artificial rainfall is a very classical topic, but some countries this is still issue. For example, UAE, United Arab Emirates, is have this kind of project, and they give money about the $5 million per year. Here for this kind of project. So if you have a very great idea about artificial rainfall, you can get money. And this is a reason why they give so much money for this research, because this country has an arid climate with less than 100 millimeters per year of rainfall, and a high evaporation rate of surface water and low groundwater recharge rate that is far less than the total annual water used in the country. So so how to get the water is a very big issue in this country. So they provide some research fund to the other countries. And this is some way to simulate the artificial rainfall. This is a cloud. They usually put some seeds in the cloud directly by the airplane, because we need seeds for the rainfall, and okay. So this is a schematic of precipitation process, and there are two types of rainfall. One is two types of cloud. One is only water, the cloud made by only water, and another one is cloud made by the ice and water. And in the tropical region, tropical countries, the rainfall is normally from the water cloud. But in the mid-latitude or high-latitude region, the rainfall is mainly come from the mixed cloud. Mixed cloud means a cloud with ice and water. So in the cloud, there is there is an updraft flow like this. So the vapor comes from here and go up to the top of the cloud. And the top of the cloud is very cool. It's very cold so this vapor will frozen and make ice. And if they make ice, the ice will be rapidly grown. So, and at some times, they can fall down because gravitation overcomes this upwelling velocity. So making ice is a very important process to make rain. And normally, the ice crystal form at lower temperature due to the this is higher temperature due to the presence of ice nuclei. In nature, the pure water never frozen by the minus 40 degrees Celsius. But if there is a nuclei, they can freeze higher than the minus 40 Celsius degrees. So they need some seas for frozen. And for example, this table shows and okay, so some aerosols, the particles in the air, can act as ice nuclei, and this figure shows the type of ice nuclei and the temperature of ice nucleating temperature of each substances. So if the if there are only pure water, the ice will made in the minus 40 degrees Celsius. But if there are some particles like mineral dust or organic compounds or bacteria, they frozen at much higher temperature, like minus 10 or minus 20. And especially the mineral dust or bacteria can be effective ice nuclei in their natural environment. And I didn't indicate it in this table, but for the artificial rainfall, silver iodine is a very commonly used for the seeds because they will freeze at the minus 4 Celsius degrees. So it's a very effective ice nuclei for the artificial rainfall. So for artificial rainfall, they inject these seeds into the cloud directly like this. Yeah, this is a kind of geoengineering, but this is not for the global warming countermeasure, but other purpose. But there are many geoengineering methods for the other countermeasure of global warming. And okay, let's go back to this slide. And I explained about the two types of geoengineering method for against the climate change. And now I will explain about the detail of these geoengineering methods. Okay, so first one is carbon dioxide removal, and the second one is solar radiation management. These two have both advantage and disadvantage. Okay, so for example, in the carbon dioxide removal, advantage is we can directly remove the cause of global warming, CO2. CO2 is a main climate forcer for the global warming. So in this method, we can directly remove the cause of global warming. And we also suppress ocean acidification as well as global warming, because CO2 is the main forcer of not only of the global warming but also the ocean acidification. So if we successfully do this carbon dioxide removal, we can solve both the global warming and the ocean acidification. But there is a disadvantage of this method. One is its cost more than or equal to greenhouse gas reduction measures. It costs too much. And another one is it takes decades to be effective. And so we have to wait for long time to see the effectiveness of this method. And there is no immediate effect. This is a problem. Okay, so then let's look at another one, solar radiation management. This one also advantage and disadvantage. And advantage, solar radiation management, this is almost inexpensive. We can just paint the rooftop with white paint, or this is not cost too much. And maybe this has the first effect to suppress temperature rise. We can expect very immediate effect by this. But this also disadvantage. This has also disadvantage, and this method doesn't lead to the solution of ocean acidification. So maybe we can solve the global warming issue, but this method cannot solve the ocean acidification. And there is a side effect of impact on precipitation, because the solar radiation is very important factor for the precipitation. So maybe this management will affect on the precipitation. And this we can expect the very immediate effect, but if we continue for several hundred years, so immediate effect means doesn't last the effect for a long time. So it's necessary to continue for several hundred years to 1,000 years, which is the residence time of carbon dioxide. So carbon dioxide lifetime is several hundred years in the atmosphere. So we have to continue this method for very, very long time. This is one of the disadvantages of this method. Okay. Yeah. Okay, let's see another the detail of this method. First is the aerosol injection to the stratosphere. So this is a okay. this is a method of the stratospheric aerosol injection, and that we can do this by the airplane or balloon or tower or a mountain top, and we use airplane or rockets like this and inject aerosol the stratosphere directly. And as I explained before, if the aerosols are injected in the stratosphere, these aerosols will stay in the stratosphere very, very, very long time. So this effect will continue for decades. But maybe this one is very cost too much. So now no one work on this method, I think. And another more reasonable method for change the albedo of Earth is aerosol injection to the troposphere. Troposphere is a very lower layer of the atmosphere, so we can easily inject the aerosols. And especially marine cloud brightening is a may be effective way to inject the aerosol to the troposphere, because we have many seawater on the Earth. And in this method, seawater is pumping up on the special ship, and sea salt particles that act as cloud condensation nucleus are seeded to the atmosphere. So we just pump up the seawater and make a spume from the seawater and inject that spume to the atmosphere. It's very easy. And and the sea salt is a very effective particles as a cloud condensation nuclei, and so this sea salt can make cloud, and the cloud can reflect the sunlight to the space. This is a concept. And okay. And another method is the increase dimethyl sulfide. Dimethyl sulfide is a precursor of aerosol made by the phytoplankton. So if we incubate a phytoplankton on the Earth artificially, maybe the precursor of aerosol, that means that this gas, dimethyl sulfide, will be increased, and this will lead to the increase of aerosols. Okay, and another indirect method is ocean fertilization. I talked about the iron fertilization in the ocean in last class, and okay, so this is an increase in the phytoplankton due to the iron fertilization. This effect was confirmed, but it is unclear how it is linked to the transport of carbon to the deep layers. So the concept of this method is iron is a nutrient for the phytoplankton, and if we put the iron to the ocean artificially, the phytoplankton will increase, and they uptake CO2 from the atmosphere by photosynthesis. And if they sink to the deep water, and we can separate this CO2 to the very deeper ocean. But the effectiveness of the carbon transport to the deep layer is not unclear so far. And we also, there are many iron fertilization experiments in early 21st centuries, but it has been reported that the carbon fixation by this fertilization may be 2 to 3 orders of magnitude less than initially estimated. It's not so effective. We found that. And in addition, the commercial ocean fertilization was banned because the impact of iron fertilization on the marine environment could not be quantitatively assessed. This is a Treaty of London, London Geoengineering, will already banned the commercial ocean fertilization because of the marine ecosystem issue. And another, 例えば OK。これはよくて。OK, so another important issue we have to think about is science and technology governance. And if we will do geoengineering, we have to think about this governance. This means there are systems that make social decisions in consideration of various problems existing at the boundary between society and science and technology. So, geoengineering is a maybe very effective countermeasure against climate change, but if we use that technology, we have to think about many things, not only the science, but also the social science or ethics. For example, if the idea of geoengineering spreads, the motivation for the mitigation measures will fade, and there is a possibility that the global warming countermeasure will decay. So geoengineering is very, なんていうのかなvery, very big project, and the idea is looks very nice. So, the motivation of the geoengineering is should be the mitigation of the global warming, but sometimes the people forget this motivation. And second one is like first one. And once a large project starts, even if the effect is uncertain and there are side effects, the project excursion itself may become a goal. So, so sometimes, if this engineering will be commercially used, there maybe some company will proceed this project even if there is a side effect. This is another problem. And yeah, third one is the rights for the geoengineering. If this geoengineering technology or rights are concentrated in the developed countries, the technology may not be used to reduce the damage in the developing countries. And the last two is the ethics issues, and besides who decides the ideal climate, optimum climate. So some are like cold weather and some are like hot weather. So who decides the optimum climate is another issue to continue the geoengineering. Okay, and so this geoengineering, the concept is we change the Earth's environment artificially. So this have an ethical question of whether we can modify the climate system. That is the base of the global environment. This is another issue for another problem for the global geoengineering. So, but now the geoengineering is very hot topic in the not only the scientists but also the social science or policy makers. But we have to think about not many things like this. Okay, I'd like to stop this class. So, are there any questions? Okay. You are following? Okay. Okay, the today's take-home message is I talked about these two topics, and the first one is IPCC, about IPCC. This is an organization where researchers from all around the world meet together gathered observation data and impacts and the countermeasure related to climate change. And they published evaluation reports once every few years, and their contents influence policy making regarding climate change. So in this part, there are not only scientists but also the government people work all together on the climate change. And the second one is geoengineering. This is a very new topic, but there are many problems. And this is a large-scale scheme with the aim of reducing the effects of climate change. And in recent years, research has been actively conducted in relation to global warming countermeasures. But there are many problems to be solved. Ethically and socially, of course, scientifically. Okay, so this is so I will stop this class.